talking about the amazing shrinking car today. But maybe not exactly the way you're thinking about it. Sure, the overall size of vehicles, for the most part, haven't changed all that much in the last couple decades. But the components sure have. Trends like ADAS, increased connectivity, and electrification have made the miniaturization of automotive components more important than ever before. And one way we can encourage innovation, reduce the weight of our designs, and keep PCB space saving in mind in our automotive designs is with a careful consideration into the connectors we use. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Kirk Ulery from Molex and I explore the role that miniaturization plays in automotive design innovation. We examine the transformational trends that are leading to smaller and smaller components, and how the right connector can make all the difference in your next automotive design. And before we get started, don't forget to click that link. There you can find even more information about this topic from Molex. Hi, Kirk. Thank you so much for joining me.
Well, thank you for having me. Really appreciate it. Look forward to our time together.
All right, so Kirk, we're talking about the role of miniaturization in automotive products today. But first, can you set the stage for us? What kind of trends are you seeing in this space?
Yes, at Molex, we see a lot of what we're calling transformational trends in the automotive industry. And there are a host of different enablers that are bringing those trends together. But what we've done is segmented those trends into four distinct areas. We start with connectivity, which refers to the fact that your vehicle is now connected in just about any situation. We're all used to being connected with our phones, with our smart TVs, and every other device. And people expect the car to be exactly the same way. Another area that we're seeing is what we call ADAS, or Advanced Driver Assist Systems. And most people, when they hear the term ADAS, they think autonomous. And long-term, the goal of ADAS is to have autonomous vehicles. But there are a lot of building blocks on the road to autonomy. If you think about your car today that has features like adaptive cruise control, blind spot monitoring, all those types of features are the building blocks to the fully autonomous vehicle of the future. The other thing to note is the in-vehicle experience. We're used to high-definition video screens, good sound quality, all those things, and we have a host of products that enable that in-vehicle experience for the end user. And then electrification is one of the factors that's driving most of the other changes. It's in the news. All the OEMs are really pushing electrification in their electric vehicle packages. And as they do the electrified vehicle, it's enabling a host of other electronic controls and features that you can put into a vehicle. Some of the design enablers we see for those transformational trends are things like V2X, which is vehicle connecting to everything. We see a lot of Ethernet coming into vehicles. Over the years, automotive devices have had a lot of non-standardized buses, or what we call a point-to-point bus. The wide availability of Ethernet controllers has caused the automotive designers to focus on Ethernet for future applications. The products that we talk about today are all ruggedized and designed for some of the harshest environments in the world.
Okay, so what is Molex doing to address these trends?
Well, in looking at the host of feature proliferation in vehicles, we started looking at today's architecture and learned that if we continued the way a vehicle has been designed over the last several years, you could end up with 80 separate electronic control units, well over 100 sensors per vehicle. And utilizing current technology, that could result in an additional 30 kilograms or over 60 pounds of copper wiring. And when you look at all the features required to put that wiring into a harness, it could add as much as 60 kilograms, which is over 120 pounds to your harness weight. So what we've done is taken these factors and we figured out ways to increase the features and content for current applications, incorporate more wires into the limited space, and that helps with weight for the vehicle, and lower weight in the vehicle drives fuel efficiency. And one of the other things we've done is as we develop higher pin count connectors, we've come up with some unique ways to lower the insertion force of the connector. If you've ever been in a vehicle assembly plant, you'll see people that are plugging the same connector in hundreds of times a day. So we need to make sure that they can do that reliably and without any type of additional strain that could lead to ergonomic factors that are detrimental to the person who's actually doing the work. So all of these factors have tied together into our need for improving our packaging from a connector standpoint.
That makes sense. Now, Kirk, why isn't bigger always better?
Well, I started my career in the computer industry, and miniaturization in computers is completely different than automotive. Even as recently as 5 years ago within automotive, we weren't allowed to use terminals that were less than 0.64 millimeters. The crop of connectors that we've got today, we're going down to a 0.5 millimeter, which in the computer and consumer electronics space is considered a large connector. But for automotive, those are smaller connectors. And we've figured out ways to make those more rugged and reliable as we get into automotive and transportation applications.
Okay, so let's dig a little deeper into these trends toward miniaturization. Kirk, what kind of architectures play into these trends, and what role do connectors play?
Well, the electronic content is growing exponentially in a vehicle. And if you think about it, the size of the vehicle stays the same. So we're essentially packing a lot more electronic content into the same space. Other things to note is that the digital devices do operate at lower power levels than traditional automotive type components. The automotive has had 12 volts as their standard DC voltage for a number of years. Most electronic devices operate at well under 5 volts, so that allows us to use smaller wire sizes to operate these devices. The other thing to note is we see a lot of what we call multifunction control units. By having multiple features in a single control unit, you can lower the number of devices or human interfaces you have. One of the key things that we're looking at is connector integration, where we're able to take data, Ethernet. We also have video signals for things like surround cameras, those types of things. And we're putting all of those features into a single connector where it makes sense. The one example I can give you right away is what we call a door connector. And if you think of the driver's side door in your car, it has a host of switches. You can control all the windows, your mirrors, a lot of other functions. And if you have a surround camera system, there's typically a camera in your outside rearview mirror. So we're able to put all of the signals required for those features in a single connector. And that's our data signal hybrid system, or MX-, that we'll be coming out with and bringing into the distribution channel starting early next year.
All right. So cars are frequently referred to as computers on wheels these days, right, Kirk?
Oh, yes.
So how does that play into this miniaturization trend?
All of our devices are getting smaller. If you watch a movie from the 70s, for example, you'll see someone carrying a cell phone in a bag, and that was considered a revolutionary trend. And now we have typical smartphones that have every feature we could ever want in a much smaller package. So we're working directly with the automotive OEMs as well as with what we call the device makers, the people that make the modules that go into those units. And we're working on consolidating things like electronic control units. And the key thing in automotive is size and weight reductions. So we've come up with significantly more electronic components within a same size package. We've come up with smaller interfaces for some standard products such as coax. And we use some of our commercial grade board stacking connectors to help shrink these devices in vehicles.
Okay, so before we dig into the details of the connector solutions in this arena, Kirk, let's talk about some terminology a bit. We're talking about solutions in the box and out of the box, right?
Yes. And when we talk about inside the box, that's typically some type of a printed circuit board stacking application. And we use the same connectors that we sell into the cell phone industry in some of the devices that go in automotive. Most of the specific connectors we'll talk about today are what we consider outside the box, where the connector itself is at the edge of the unit and it connects either to a wire to another box, or in some instances, it's a wire-to-wire system where you have two pieces of a harness that may be assembled separately in the vehicle assembly plant, but need to be connected before the vehicle gets shipped.
Okay, so what kind of solutions does Molex have for outside the box?
We've segmented our products in this particular slide to talk about our 0.5 millimeter solutions, which are the newest products that we brought to market. We've got Contact 50, Stack 50H, as well as Mini 50. And in automotive, when we talk about connectors, we typically add a number, and the accepted terminology is the number is the width of the male blade terminal. There are one or two exceptions to that, but generally if there's a number beside the connector, it refers to the size of the male blade. So continuing on that, our MX64 and our Stack64 are a 0.64 millimeter wide terminal. We have some other products, such as our MXP120, which is a 1.2 millimeter product. So if you get into automotive terminology, that's just something to remember as we go forward. Some of the other miniature solutions that we have are DuraClick, which is a 2 millimeter centerline product. It's a wire-to-board product that's found great success in automotive. And then we have our Mizu P25 and our Scuba 25 system. Those are sealed wire-to-wire systems that are used both in automotive and a lot of other transportation applications. And then in terms of a preview of coming event, the HFM, which is our high-speed FACRA mini product, we're currently providing that directly to OEMs, and we'll be bringing that into the distribution channel early next year also.
Okay, so can we take a closer look at those DuraClick solutions you mentioned?
Certainly. DuraClick is our fastest growing distribution product over the last 3 years. It's a 2 millimeter centerline wire-to-board system, and it was originally designed to be very highly reliable. We offer latching features, terminal retention features that go into every automotive grade connector we make. And with DuraClick, we've seen a huge expansion through the distribution channel into markets outside of automotive. It's still primarily used in transportation, but we've got a host of other applications for it. The key things to note is that the standard operating temperature is up to 125 degrees C. It's not a sealed connector, but it does offer circuits from 2 to 15 circuits. The PCB header is a surface mount product, and it does meet US CAR and LV214, which are the two global automotive industry standards that cover a lot of the connector development that we perform. The name itself for DuraClick comes from durability plus an audible click sound. And most of the automotive connectors we have, when you mate them together, you can hear them click. And that's a requirement of all of our OEMs.
Okay, so what specific applications would the DuraClick be a good fit for?
Well, the original design for DuraClick was in automotive lighting assemblies. And if you've ever had to replace the headlamp in a current vehicle, you know that it's a full assembly, and it's nowhere as cheap as the light bulbs that we used to get to replace when a headlight went out. So within the typical headlamp assembly, you may have 2 or 3 stacked boards, and DuraClick gives you a great way to connect those boards with a small wire to PCB system. Other areas we're seeing is in service modules, motor controllers, and LED drivers. And outside automotive, we've got some great applications within induction cooktops. The high temperature range of DuraClick was a key factor for the OEM that decided to use this, and they're very happy with the performance. It gives them a very reliable product at a very reasonable cost.
So, Kirk, specifically for my audience who wants to keep space saving in mind in their next automotive design, what Molex solutions would you recommend?
Well, we've highlighted here what we call our miniaturization portfolio. And we see a lot of applications with these for customers who are looking for a smaller, more reliable system. The Mini 50 system was designed around US CAR, which is the United States Consortium on Automotive Research. They define a lot of the testing parameters as well as some of the interface dimensions for these systems. And all of the North American OEMs are very strict about parts having to meet US CAR. Our Mini 50 is available in circuits from 4 to 38. It's on a 2 millimeter pitch and can handle currents up to 4 amps, which is dependent on the wiring size that you use. The Contact 50 is an AK or European style terminal. So if you have a customer that might be more European based or wants to sell products into Europe, Contact 50 would be a great choice. The headers on the Contact 50 are available in both right angle and vertical, and we've got a unique side latch that gives you a very low profile. So if your customer's looking for a connector that's going to help them with a short unit, the Contact 50 is a great application for that. This one's available up to 22 circuits and can handle up to 6 amps, again, depending on the wire gauge. The two other parts we're showing here are Stack 64 and our Stack 50H. The Stack 64 is another lower profile system. One of the key features of both of these products is the ability to stack side by side the different header configurations. This gives your OEM a chance to come up with a modular design and some flexibility without having to tool a brand new connector for every single application. The Stack 64 goes up to 80 circuits. It's a 2-row system. The Stack 50H is a little taller, but stacks better side to side. So if you've got a narrow unit, the the Stack 50H would be a great application there.
Okay, so what applications would these connectors be a good fit for?
One of the big growth areas for us has been in infotainment modules. I mentioned earlier that whole in-vehicle experience that people are looking for. There are a lot of signal wires within the vehicle that have to go into the module. The Stack 50H offers a hybrid terminal system, meaning that in addition to the 0.5 terminals, we can also put a 1.2 or a 2.8 terminal blade, which gives you the ability to have enough power coming into the unit that you can run it with a single connector plugging in. Another area where we're seeing a lot of growth is in battery management systems. As vehicles become more and more electrified, one of the key concerns is the temperature of the battery packs. There's been a lot of press recently about, are electric vehicles safe? Are battery packs safe? Every couple of months, you'll see on YouTube an electric vehicle that happens to catch fire. And we're using our miniaturization profile products to help the OEMs build systems that can monitor the temperatures inside the battery pack. Some other areas we're seeing are collision avoidance systems, domain controllers. There are just a host of applications that our miniaturization portfolio is an excellent choice for.
Okay, so speaking of EVs, EV design is a huge topic these days. Would any of these connectors work for an EV design?
Absolutely. The one we're showing here with our Mini 50 is an EV inverter. And the inverter is designed to convert either DC to AC or AC to DC, and typically part of the charging circuit. There are two distinct methods for charging an electric vehicle today. The standard J1772 is an AC system, but then they also have what they call DC fast charge. And within the vehicle, the inverter has to understand what voltage is coming in and make those changes. In this case, the Mini 50, which is the only interface that met the US car 0.5 millimeter standards, is used for the control circuit on the EV inverter. We had a sealed option because they needed it splash-proofed under the chassis, and we also gave them the option for various circuit sizes so that the OEM was able to scale from the low-end vehicle to the high-end vehicle and still use the same interface for the Mini 50.
Okay, so do you have any other cool applications you can share?
Yes. We're working with another OEM on an electric snowmobile. As we're all aware, everything's becoming more electric. And within the electric snowmobile, we have a host of our products designed in. We used Mini 50 for one of the I/O connectors, but then we've also used some of our standard commercial products that you may be more familiar with in terms of FFC, FPC products, as well as some of our easy-on PCB type products. In this case, the OEM had a host of different requirements, and Molex was able to provide 6 or 8 different solutions for them and allow them to choose the parts that met their needs best. The key for all of these parts is they were concerned with high vibration. Even though the electric motor doesn't have a lot of vibration, if you've ever ridden a snowmobile on an icy road, you get a lot of vibration. That was one of the key factors that led to the OEM selecting a host of Molex connectors.
Now, I believe you mentioned that the DuraClick would be a good choice for a headlight application. So tell me about that.
Yes. As I mentioned, it was originally designed for automotive headlights, but we're seeing applications across the industry. In this case, we're highlighting a motorcycle headlight, which is one of the largest global OEMs of motorcycles. And in this case, they chose the DuraClick because they needed a very robust micro-miniature wire-to-board product. The headlamp assemblies today are typically sealed, and you may have a dozen or so LEDs that all need control circuits, and there are different features within the headlight. The wide temperature range was also a key factor, although I'm not sure I know anyone who's willing to ride their motorcycle when it's 40 below. But in this case, the product itself can handle those temperature extremes and then up to 125 degrees C. The other thing to note is that the terminal retention force was a key requirement for the OEM. Once they build the headlamp unit, it's ultrasonically welded together, and they don't want to have to change any of the connectors inside because that would require a complete disassembly of the headlamp.
So what about that Stack 50H connector solution you mentioned? Do you have an application you could share for that connector as well?
Well, yes. In this case, we're highlighting a high-performance mobile heating, ventilating, and air conditioning system. And this picture highlights the stackability of our products. You'll see that the 3 headers that we have here are all molded separately, but we lock them together with a single metal clip. And the reason we use the different colors is to give a visual indicator to the installer of which connector goes into which header. So here we've got the 3 different headers, and each header has a slightly different pin arrangement. In this case, the OEM was looking for a robust interconnect for a ruggedized HVAC that goes into a transportation. In this case, it's actually an RV application. Because of the hybrid capability, they're using both 0.5 millimeter and 1.2 millimeter terminals, so they bring power into the control unit as well as all the required signal lines. And they're already looking at adding another module for the higher end unit. So the stackable side-by-side configuration means that they can use the same cable assemblies for the existing features, but as they add more features, it's just one new cable assembly as opposed to having to completely redesign their wiring system.
Okay, so Kirk, can you recap your main points for me?
Yes. What we want to do with our distribution partners is work with customers and think both inside and outside the box. The products we're highlighting here have been primarily outside the box, but there are a lot of applications inside the box that sometimes get us the entire system. The important thing is to understand where our customers are going, and we can work together to achieve those goals. If you think about the automobile as a connected system, we've talked about a data center on wheels, the in-vehicle experience. Remember that Molex has all the solutions required for these applications.
Okay, Kirk. So can you pick 3 takeaways that you'd like my audience to remember from today's Chalk Talk?
Yes. The key thing to note is that the market trends are creating opportunities for both of us. There are a host of people that are looking at new opportunities within transportation and other ruggedized applications that don't understand the connector piece of it. So by focusing on those market trends, we can get the information to our customers so they understand to use our products. The other thing is focus on the application, and that gives us options. We've shown a host of connectors here that meet a wide range of applications. Within automotive and ruggedized connectors, the connectors themselves typically do not have a specific purpose. They're designed for an environment, for specific current ratings and wire sizes. So there are a host of options that our customers can use. What we need to do is work with our customers to make sure that they understand the breadth of the Molex portfolio. And then the final point is to remember that core products are fundamentally important. When people think of a new design, they usually think of, well, I need a brand new connector. But the products I've shown today are all core products that are tooled, readily available, and most of these are already on the shelf with our distribution partners. So that's fundamentally important to growing our business. Even though people would like a brand new connector, one thing they want even more as they're in the design is one that they can get right away. So we've got products that you can get right away, and that's fundamentally important for both of us as we grow our business together.
Excellent. Well, Kirk, I think that's all I have time for today. Thank you so much for joining me.
Well, you're welcome.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Molex. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it. It's right across the top. Or head on over to YouTube, youtube.com/EE Journal.